Hello everyone, so this is the last section of Unit 4 before a Unit 4 test, and it's all about L'Hopital's rule. So we're going to go ahead and revisit an old concept from Chapter 1, all about limits. And some of you are going to kind of wish that I would have taught this to you sooner. Maybe would have made some of the problems from Unit 1 a little bit more simple. But I don't know why College Board has it in this sequence, but they wanted to teach L'Hopital's rule here instead of in Unit 1. So something you should recall is some of the special trig limits is that if you have the limit as x approaches 0 of sine of x over x, that should equal to 1. And if you have the limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. So yes, I did say in the past that these are equations or formulas that you need to memorize for the test, but you will actually be able to prove these two using L'Hopital's rule. So if we go ahead and revisit kind of a problem that we saw earlier in Unit 1, you can remember that I would ask you to evaluate something like this. The limit as x approaches 2 of x squared minus 7x plus 10 divided by x minus 2. So if we did this from, similar to how we used to do it from Unit 1, it'll look something like this. We would say, okay, well, if we plugged in 2, we would get like 0 on the bottom and 0 on the top. So we're going to have to figure something out to see if we can cancel. And you'll notice that this is something that we can factor. So we have the limit as x approaches 2. And if we factor the top out, we would have factored that out into two numbers within positive 10 that add up to negative 7 is x minus 2 and x minus 5, all divided by x minus 2. You'll notice you can cancel the x minus 2's, and when you plug in 2 into this, it will no longer be indeterminate. We can actually get plug in 2, and we get 2 minus 5, which is equal to negative 3. On the other hand, we have L'Hopital's rule. And this essentially what we can do here is that if we have something that's 0 over 0 or infinity over infinity, whenever we plug in our x, like whatever x is approaching, into our function, this is considered to be indeterminate. And whenever you have an indeterminate limit, what you can do is you can do L'Hopital's rule. And essentially what you have to do is take the derivative of the top function and the derivative of the bottom function, not to be confused with, let me make a note of that. Not to be confused with quotient rule. Yes, most of these problems are going to be in the form of a quotient, but what you have to do is take the derivative of the numerator and the derivative of the denominator and just kind of rewrite a new numerator and a new denominator in the forms of their derivatives. So the way that that'll look is you're going to have the limit as x approaches 2 of all of this. That's right. Let me just rewrite it. X minus 7x plus 10 over x minus 2. If you use L'Hopital's rule, what you can do is take the derivative of the top. So it's going to be the limit as x approaches 2. Derivative of the top is just going to be 2x minus 7 divided by the derivative of the bottom, which is 1. Then if you plug in 2, you'll get 2 times 2 minus 7. 4 minus 7 is negative 3. And you end up with the exact same thing. This is another tool that's going to be very handy later. So, let's just kind of go through it. Now, here's the thing. When I was in college, and even when I took the AP exam, for calculus several years ago, what we were allowed to do, we were just able to say, okay, well, this is equal to 0 over 0. And then we could just say, use L'Hopital's rule. And then we would just go about our business, take the derivative of the top and the bottom, then just plug it in, and that was good enough for the AP readers. I mean, I'm still not 100% sure about this. I'll probably post make a post on like a Facebook community page for calculus, but from a few teachers that I've looked into who have read AP exams in the past, they say that now there's an entire protocol that you have to follow for the AP exam. In other words, you have to do each of these steps in order to be able to do L'Hopital's rule. So first thing you got to do is you have to explicitly show that the limit of the numerator is 0, infinity or negative infinity. Then you have to explicitly show that the limit of the denominator is 0, infinity or negative infinity. All right. Then right after that, they say that they would want you to state that the limit is indeterminate form because they are both 0 or positive or negative infinity. Then by L'Hopital's rule, you're going to rewrite your limit with the derivatives, And then from there, you take the limit. So you have to follow this, as far as I know, you would have to follow this step-by-step process every time you do a L'Hopital's, or every time you want to use L'Hopital's rule. So I have some stars. I'm not going to do all of these problems. You can just look at the filled in notes inside of Canvas. But I'll just go ahead and do an example of what I assume is what you have to do. So the first one, you have to prove that the top limit is equal to either 0 or infinity. So I'll go ahead and do that. So you have the limit as x approaches -5 of the square root of 4 minus x, and then all of that minus 3. And if I plugged in -5 into this, that'll be 4 plus 5, square root of 9 is 3, 3 minus 3 is 0. Next thing, I'm going to go do the, the limit as x approaches -5 of the denominator. So if I plug in -5 into this, -5 plus 5 is in fact 0. So again, I did the first two things from my steps. I have to explicitly show that the limit of the numerator is 0 and that the denominator is also 0. Then the third thing we have to do is we have to go ahead and say that it's indeterminate. Use L'Hopital's rule. And then from there, that's when you finally can go ahead and do the process. So I'm going to rewrite my limit. So as x approaches -5 of the square root of 4 minus x minus 3 over x plus 5. So all right, if I took the derivative of the top, well, that'll, let me just do it on a sticky so you can kind of see how I got to the next step. That's the same thing as saying 4 minus x to the 1/2. And if I were to do chain rule with this, I can bring the 1/2 to the front, keep the inside, subtract 1 from the numerator, then multiply by -1, right? So when and then when I do this whole derivative, that's this like, -1, I'll just leave it on the top, 2 stays on the bottom, this goes down to the bottom with it, right? So I know that the derivative of this is equal to -1 over 2 square root of 4 minus x. Well, derivative of that is just going to be 0, so it'll be all of this minus 0, and then divided by, if I took the derivative of the bottom, derivative of x is just 1. So, I mean, this minus 0 divided by 1 is just this itself. So that's equal to the limit as x approaches -5 of -1 over 2 square root of 4 minus x. So now if I went ahead and plugged in -5 into this, that's going to be the same thing as -1 over 2 times the square root of 4 plus 5. So then that'll just end up being -1 over 2 times 3, which is 6. All right. So yeah, we could easily do L'Hopital's rule for this. Some of you probably might want to rationalize it or multiply it by the conjugate. That's either way is fine. But for the purposes of this problem set, I just want you guys to use L'Hopital's rule just to make sure you have an adequate amount of practice. So let's go ahead and do a trig function. So this is actually kind of similar to what we did up here. I probably, in hindsight, I should have proved these two, but we'll do that at the end. So if I wanted to do L'Hopital's rule with this, again, I have to go ahead and prove that the numerator and the denominator as the limit approaches 0 is going to equal 0. So it's going to be the limit as x approaches 0 of sine of 6x. Well, if I plug in 0, sine of 0 is in fact 0. And then I got to do the limit as x approaches 0 of the bottom, which is 0. So from there, we can go ahead and say that it's indeterminate. Use L'Hopital's rule. Right? We'll write it out. I'm just shorthanding it to not make this video longer than it could be. So now I'm going to go ahead and rewrite by limit. So the limit as x approaches 0 of the sine of 6x over x. I go ahead and say by L'Hopital's rule that this is going to, I'm going to take the derivative of the top. So that's going to be the limit as x approaches 0 of the top, which will be cosine of 6x times the derivative of the inside, all divided by 1. So now if I plugged in 0 into this, that's going to be cosine of 0 times 6. Cosine of 0 is in fact 1 times 6, which is 6. All right. So just to kind of go back on like these proofs over here, If you plugged in 0 into this, you would get 0 over 0. And if I took the like the derivative of the top and the bottom sine, like the derivative of sine of x would be cosine of x, and then the bottom would be 1. So if I took the limit as x approaches 0 of that, you will in fact get 1. And I'm guaranteed that if you work this one out, it should equal 0. So I figured I'd just clear my conscience and get that taken care of. So let me go into the next page. So the next limit that I want us to work out, or that I want to work out in this video, and I kind of already did this problem in the front, so sorry about that. But I want to go ahead and work this one out, because this is an example where you're going to have to do L'Hopital's rule twice. And again, this is something that I know I have to ask the AP community to see what the exact format is that they're looking for in the AP exam. But for now, I'll just kind of shorthand it and then like inform you guys soon enough. So first thing we got to do is prove that it's going to be 0 over 0, and by explicitly taking the derivative of each. So the limit as x approaches 0 of 1 minus cosine of x. If I plug in 0 into this, cosine of 0 is 1. 1 minus 1 is 0. Then I'm going to do the limit as x approaches 0 of x squared, which is in fact 0 if I plug it in. So we know that this is indeterminate. Use L'Hopital's rule. Okay, so I'm going to go ahead and rewrite this. So I have the limit as x approaches 0 of 1 minus cosine of x over x squared. That's going to be the same thing. So by because of L'Hopital's rule, we can go ahead and say that the derivative of the top is going to be, let's see, derivative of cosine is negative sine. With a negative, we'll make it a positive sine of x. Obviously, that's 0 divided by 2x. Now, here's the problem. If I plugged in 0 into this, well, sine of 0 is 0. And then the bottom is obviously going to be 0 again. So we have to use L'Hopital's rule again. Okay? So I'm going to just rewrite this part. So I have the limit as x approaches 0 of sine of x over 2x is equal to the limit as x approaches 0 now of cosine of x over 2. And then if I plugged in 0, I'll end up with 1 on the top and 2 on the bottom. Okay, so yes, it didn't. We used L'Hopital's rule and it didn't work out for us the first time. But the nice thing about this rule is you can use it multiple times and then you can eventually get to the right answer. I've seen problems in the past where I've had to do L'Hopital's rule about 3 or 4 times to finally get to the answer that I wanted, and sometimes that'll happen. So if I go ahead and do this problem now here's an example where we have as x approaches infinity. So we'll kind of see what that happens, because really all of the examples I've done so far is where you have 0 over 0. So let's see what happens when you do infinity. So I'm going to do explicitly do the limit of the top. So that'll be the limit as x approaches infinity of 4x squared minus 3x plus 2. I hate having to write all of this. I just wish I can say this is equal to infinity over infinity. But I mean, if that's what the AP exam wants, that's what we got to give them. So this is equal to 0. Then we got to also do the limit as x approaches infinity of the bottom. So e to the 2x plus the natural log of x. And that's also equal to infinity. So if we have infinity over infinity, we have it's indeterminate. Indeterminate. So by L'Hopital's rule, all right, we're going to go ahead and rewrite this limit. So the limit as x approaches infinity of 4x squared minus 3x plus 2 divided by e to the 2x plus natural log of x. That's equal to the limit as x approaches infinity. So the derivative of the top, we're going to bring the 2 to the front. So that's 8x minus 3 over. And then if I took this, I'm going to do, let's see, that's 2e to the 2x plus 1 over x. Or you know what, let me write it as x to the negative 1 power. Sorry, that got really ugly there. Okay, so let's see. Well, if I plugged in infinity into this again, though, I'll have infinity on the top, and then on the bottom, well, e to the infinity will be infinity. This will make this whole thing infinity. And then even though this will be 1 over infinity, it'll be 0 plus infinity, so it's also going to be infinity over infinity. So I'm just going to do it again. So by L'Hopital's rule again, and I made a note in my previous stuff to make bigger boxes for this, so sorry that I'm squeezing it all in this one. I could do the limit as x approaches infinity of 8x minus 3 over 2e to the 2x plus x to the negative 1. If I took the derivative of each one separately, that would be the limit as x approaches infinity of 8 now on the top over 4e to the 2x, because it'll be e to the u times the derivative of the exponent. And then power rule, what that would make this minus 1x to the negative 2 power. So now if I plugged in infinity into all of this, I'll end up with 8 over infinity, and 8 over really big number is just going to be 0. All right, so you can go ahead and work this example out on your own. And one of the things that I on my notes, I did this using L'Hopital's rule, but apparently it's just as fine to just say that L'Hopital's rule is not necessary. And you can just use, so just use end behavior. All right, so there's one more problem I want to do with you guys on this, because these are AP style questions that I would like for you guys to try on your own and then go ahead and look at the solutions on Canvas, because remember, I always have the blank notes, then the video, and then the filled in notes at the end. So these I want you to actually try on your own, because these are kind of like more AP style, but I do want to do the last one with you guys. Okay, so that problem that I want to do is this very last one, and it's because, I mean, it goes over some concepts that I think was taught in Algebra 2 or in Pre-Calc, but I'm starting to think maybe it wasn't. So I feel like, let me just kind of go over a concept like this. So if we say find the limit if possible, give a reason for your answer. All right, so we know, let's just go ahead and do our process for L'Hopital's rule. We'll take the limit of the top, so the limit as x approaches infinity of 2 to the x power. If I plug in infinity, that'll be infinity. And the limit as x approaches infinity of x to the 99th power, well, infinity to the 99th power will also be infinity. So we know it's indeterminate. Okay. So then if we do by L'Hopital, well, here's the thing. So we can use L'Hopital's rule. But the problem is, if I did the limit as x approaches infinity of 2 to the x over x to the 99th, well, I dare you to try to do L'Hopital's rule with this. But what we can say with this is that this is equal to infinity, and it does not exist. Okay? And there's a reason for that, because what we need to, something I've never, I imagine was taught, but maybe it wasn't, is what is the hierarchy of infinity. So let's do that. Let's consider, and maybe this will just kind of be like part of your notes. So consider the hierarchy of infinities. Okay? So as x approaches infinity, yes, this will be infinity and this will be infinity, but this is kind of going at a much faster rate than this one. It's very similar to like when back in the day when we did problems where if we had like x over x squared. Sure, if I plug in, or let's do plus 3 so that they don't just cancel out, and plus 1. So if I plugged in infinity, yes, this will go to infinity and this will also go to infinity, but this one is going at a much faster rate. So then we would say, well, if this is going at a faster rate, then a big number at the bottom would mean that the whole thing is equal to 0. But in cases like this one is actually going at a much faster rate than this one, and it's because of the hierarchy of infinities. All right, so, and I don't really see this in any textbook, so I'm just kind of going off the top of my head from what I learned in college, but there is a hierarchy. So factorials are always going to be the biggest type of infinities, or the fastest rated infinities. And that's, if you have x to the factorial. Those will always be greater than exponentials. Right? Exponentials being like e to the x. or 2 to the x, or maybe 3 to like square root of x. Just examples like that where you have like an x and an exponential. But now exponentials will always be go at a faster rate than polynomials. Polynomials being just your regular, I don't know, maybe square root of x, or x squared plus 1, or maybe even something a little bit more complicated like x to the 1 plus x squared. These are examples of polynomials, and polynomials will always be at a faster rate than logarithmic functions. Those are usually the slowest logarithmic functions, right? Those are usually the slowest ones. That's like your natural log of x, or natural log of x, I don't know, cubed, or maybe even the natural log of the natural log of x, right? So this is kind of the hierarchy that you need to follow, right? So, I mean, I don't know, maybe just kind of keep that in your notes somewhere. So if I ever have the limit as x approaches infinity of 2 to the x power of x to the 99th, well, here we have a polynomial, and here we have an exponential. Exponential, right? Exponentials, as x approaches infinity, it goes at a much faster rate than polynomials do. So really, if this is going at a faster rate to infinity than this one, then the whole thing will just be equal to infinity, or does not exist. All right, so maybe that was something new that you taught, maybe it wasn't. I don't know. I'll find out soon enough. But hopefully that was helpful. If you still have any questions, then you are more than welcome to ask me, and hopefully you can get started on the problems that I don't understand it. Take care.